when we want to sketch something, there is a connection between Cartesian equation and solving equation. So this is a Cartesian equation. Y equals to 2x plus 1. Now this is a solving equation. 2x plus 1 equals to 0. Now we know what this picture looks like. It's a line. And we know when we solve this, x equals to minus half. So when we send both sides, we subtract by 1, and then both sides we divide by 2. It is minus 1 by 2. Now the question is there any connection between the two? Well, this is the connection. When a Cartesian picture cuts the x-axis, so if this is the x-axis, that is the solution of the equation. So if you put y equal to 0, x equals to minus half, that means this is where the picture cuts the x-axis. That's what it means. So if you want to solve this, suppose you are asked for an equation, solve this equation, x squared plus x minus 6 equals to 0. And you know how to solve this. You can solve this using quadratics factoring rule, middle term break. We can do x squared, 6 1 the 6, so thrice x minus twice x minus 6 equals to 0. We can take x common and it becomes x plus 3 minus 2, x plus 3 equals to 0. And we can write x plus 3, x minus 2 equals to 0. So therefore, x equals to minus 3 or x equals to 2, we have two roots. Remember, a quadratic equation can have at most two roots. Now, this is the same as visually having a sketch of y equals to x squared plus x minus 6 and finding out where it cuts the x-axis and y-axis. So if you want to solve this equation visually, it is the same as finding it where it cuts the x-axis. So it cuts the x-axis at minus 3 and it cuts the x-axis at 2. So that's it. That's what it is. So this is very, very important that you remember that. A solving equation, meaning something that has one variable, can be solved using algebra, or you can take it as the Cartesian equation where we have two variables x and y and have a picture of it. The solution is where does the picture cut the x-axis. Remember, at the x-axis y equals to 0. This is the connection at the x-axis y equals to 0. So now we can use this concept to do the reverse. So for example, you're asked to sketch an equation y equals to x minus 3. So now you can find out where does it cut the x-axis. So you can write when y equals to 0. X-axis means y equals to 0. Now it becomes a linear equation. So we find the root of the linear equation. So that means at the x-axis this picture will cut at 3, and it doesn't have to be very accurately. It could be quick and dirty. That's it. Now you want to find where does it cut the y-axis. So when y equals to 0, when x equals to 0, in this vertical number line x equals to 0. So we can write y equals to 0 minus 3, which is minus 3. That means this is minus 3 and we join it. That's it. That's the line. So we can go now back and forth using the concept of algebra where we solve equations, and using that we can sketch it. So let's do another one. We can try a cubic. So y equals to, since cubic require factoring in a special way, I'm going to give the factors. So suppose x plus 1, x minus 1, x minus 3. So we want to sketch this. So this is the same as solving a cubic equation. X plus 1, I'm giving the factors so it is easier to find the roots now. So we have three values. X equals to minus 1, or x equals to plus 1, or x equals to plus 3. So we have three values, which is the same as this picture cutting the x-axis. So we can write at x-axis y equals to 0. So we convert the Cartesian equation into a solving equation. Always remember, there is a very important link between solving equation that we solve by algebra and Cartesian equations, the pictures. So we have three values of x, minus 1 or 3. And we can also find out where it cuts the y-axis, where x equals to 0. So y equals to, so 0 plus 1 is 1, 0 minus 1 is minus 1, 0 minus 3 is minus 3, which turns out to be 3. So now So it cuts the x-axis at -1, x-axis at 1, and x-axis at 3. It's a sketch. It doesn't have to be that accurate. So, and we know the shape. It cuts the y-axis at 3. And we know the shape that x cubed, because if you multiply this thing, x into x into x is x cubed. X cubed looks like something like this. Plus x cubed looks like something like this. And minus x cubed looks like something like this. So you remember this shape. So the shape would be like this. That's it. Now since this is -1 and this is +1, the turning point would be exactly in the middle. Now on the other hand, if it was like this, suppose this is -1 and this is 5, remember the turning point would move towards here, around here, in the middle. The middle is here. You cannot always think that the turning point is the y-axis. Now you would lose mark for that in the exam if you use that. So be careful. The turning point has to be somewhere in the middle of the two values. So that's how sketching works. Let's do another sketching. Suppose you have y equals to x minus 1, x minus 1, x plus 7. Okay, let's convert into an algebra. So y equals to 0 means where does it get the x-axis, or just converting this into algebra. Now you have this x equals to 1 or x equals to 1 or x equals to -7. Then where does it get the y-axis, where values of x is 0. So y equals to 0 minus 1 is -1, 0 minus 1 is -1, and 0 minus 7 plus 7 is 7. So -1 minus 1 is 1, into 7 is 7. So let's do this sketching. Now we have 1 over here and -7 over here. This is a bit strange because if it's a cubic, it is supposed to cut the x-axis at 3 points. In other words, it is supposed to have 3 different roots for this equation, but it has 2 different roots because 1 and 1 is the same. So we have 2 roots, 1 and -7. In situations like that, you have to remember where the roots are repeated. This one, x equals to 1 and x equals to 1, this one. Whenever the roots are repeated, that becomes the turning point. This would be the turning point. We know the shape is this. And the turning point is going to be, one of the turning point is going to be here in the middle, somewhere around here. So this is going to be 1, and the other turning point is going to be like this. It's not going to be cut the x-axis, it's going to touch the x-axis at that point. So remember that. Another thing to remember, one of the turning point is going to be at the repeated root, but the other turning point cannot be at 7. This is a very common mistake. To suppose if this is -7 and this is 1, you cannot always think that the turning point would be at the y-axis. No, the turning point would be around here in the middle of that. Okay, now there is one more concept about Cartesian equation and solving equation. Suppose you have two Cartesian equations, y equals to 2x plus 1, and suppose you have y equals to x squared plus x minus 1. Now remember, when you have two Cartesian equations, the picture is, so this is like this. So -3 and 2, it cuts the x-axis at -3 and 2. This is, let me make this -6. So this is -6. And this is -half and 1. So this is this. So these are the two pictures. So this is the same as solving simultaneous equation y equals to 2x plus 1, equation 1. Y equals to x squared plus x minus 6, equation 2. So how do we solve it? We can solve this by substitution. X squared plus x minus 6 equals to 2x plus 1. We can write x squared x minus 2x is minus x. We can write -7, and we can solve this. We can find two values of x. This is the same as finding the point of intersection of these two pictures. So remember, in Cartesian, solving two simultaneous equation graphically is finding their point of intersection. So the x value over here, this is one of the root, and this is another of the roots. So if you want to know how many roots this equation will have, you can say visually they will have two roots. Why? Because these two pictures, since they're Cartesian, they're going to be pictures, intersect at 2 points. Now let's do some other sketching. So when we have a rational equation like that, suppose you have 2x plus 3 divided by x minus 1. So now this is a bit different. It's a rational equation. It's going to be like this. Let's find out what is the x-axis. So when y equals to 0, we get 2x plus 3 divided by x minus 1 equal to 0. Since you multiply with this, it becomes 0. We can write 2x plus 3 equals to 0, therefore x equals to minus 3 by 2. So this picture cuts the x-axis at the point minus 3 by 2. So here minus 3 by 2. Let's find out what is it at the y-axis. Y-axis means x equals to 0. Let's put x equal to 0. It becomes 3 divided by minus 1. So 0 plus 3 is 3 divided by minus 1, which is minus 3. So minus 3 is somewhere around here. So that's where it cuts the x-axis and y-axis. So if you write it as points, the x-coordinate here is minus 3 by 2 and the y-coordinate is 0. The x-coordinate here is 0 and the y-coordinate is minus 3. Now remember, when you have this rational equation where you have x both upstairs and downstairs, we have a concept called asymptote because numbers cannot be divided by 0. So in the basic format, this is what it might look like. If we have 1 by x and if we have x equals to 1 by y, it's the same thing rearranged together. So the original picture, it has two different broken lines, meaning this line cannot be crossed. So similarly, since we have this x downstairs, it can be rearranged to write as y downstairs. We can have two different broken lines. They are known as asymptotes. So now there is a cool trick to remember what the asymptotes are. First of all, take what we have downstairs and make it equal to 0. So when you make x minus 1 equal to 0, it becomes x equals to 1. This is one of the asymptotes. So let me write this one of the asymptotes. So this is one of the asymptote, x equals to 1. Now for the other one, take the coefficient of x and take the coefficient of x downstairs and upstairs. So this is what we have, coefficient of x, coefficient of x. That makes it y equals to 2 by 1 or 2. So the other asymptote is going to be y equals to 2. So we have this value and we have this value. So we have the two asymptote. Now we know the two boomerang shape where they're going to be. So one of them, since they cut the x-axis and y-axis, is going to be this one. So we can draw one of the boomerang like this. It's this one. And the other one is this one. Always the opposite. So that's it. That's a special sketching. Now, it is often seen that quadratic equation sometimes does not have any root. We cannot find any solution. For example, there is a solving equation, x squared plus 1 equals to 0. Now what does that mean? We cannot solve it. X squared equals to minus 1 and x equals to plus minus square root of minus 1. If we bring out our calculator, so this is what it looks like. If you write square root of minus 1, that's math error. So what do we do in this situation? What does that mean? Well, visually, it's very simple. It means the picture, if you remember, y equals to x squared is this specific shape and y equals to x squared plus 1 is slide upwards by 1 unit. So remember, so this is what the picture looks visually. It means it doesn't cut the x-axis at all. Remember, the root of an equation is where does the Cartesian equation cut at the x-axis. So when we have regular equations, it means we just solve it, we find the value. But if we cannot find the value, or if you want to know the connection of solving it graphically or visually, it means where does the Cartesian picture cut the x-axis. So here, for this particular quadratic equation, it doesn't have any root because the Cartesian equation doesn't cut the x-axis at all. Now, if we have an equation that looks like this, it has only one root, one unique root. So what might be an example of this? An example of this might be X squared minus 2x plus 1 equals to 0. If we solve this, it becomes complete square. X minus 1, they are the factors. And we solve x equals to 1 or x equals to 1. So they are the same. It means it cuts the x-axis at one point. So visually, so the equation of y equals to x squared minus 2x plus 1, this is what it looks like. If we have two values of x, it means that is the turning point. And of course, if there are two different roots, it would cut at two different points. So that's it. So by definition, a quadratic equation can have at most two roots, meaning it can cut the Cartesian quadratic equation can cut at 2 points, it can cut at 1 point, and it might not cut the x-axis at all.